This is geometry, section 3 on congruent triangles. First off, what does it mean for something to be congruent? For two things to be congruent, they need to be exactly the same shape and size. We use this mark, an equal sign with a tilde mark on top. This represents congruent. Okay, so when you see that mark, that means that two things are congruent to one another. If we have two congruent polygons or triangles, if we have two congruent polygons, this means that all of the parts of one polygon are congruent to the corresponding parts of the other. So essentially, if we have two polygons here, and if we want to say that these two polygons are congruent, they need to have congruent corresponding parts. So those two sides would need to be congruent to one another. These bottom two sides would have to be. The right-hand side would have to be, and the top-hand side would have to be. Not only the sides, but it also refers to the angles. So these two angles would have to be congruent. These two would have to be. These two would have to be, and those two would have to be. When you have that case, then we know two polygons are congruent. So now there's an acronym that we're going to use to help us describe when corresponding parts are congruent, and that's CPCTC. We're going to use this a lot when we're trying to prove triangles congruent. What this stands for is corresponding parts of congruent triangles are congruent. So what exactly does that mean? That means that if we have two triangles that are congruent, so here, let's say we have triangle ABC is congruent to triangle DEF, the corresponding parts of those triangles would have to be congruent. And we're going to get into more of that in this first example. So this first example, we have two triangles which are drawn out, and they definitely do look like they are congruent. They have corresponding marks, and we want to show that the polygons are congruent by identifying all the congruent corresponding parts. Then write the congruency statement. So what we're going to do is we're just going to look and we're going to determine which parts are congruent to which parts. So here we see that side JP and side TV are congruent. So we'll say TV is congruent to JP. We see side PL and side VS are congruent. So side VS is congruent to side PL. And we see ST and JL are congruent. So side ST is congruent to side JL. So those are our three congruency statements for the sides. Now we're going to do the same for the angles. Here we see angle J and angle T are congruent. So angle J is congruent to angle T. We see that P and V are. So angle P is congruent to angle V. And then we see that S and L are marked congruent. So angle S is congruent to angle L. So there we wrote down all the congruency, we identified all the corresponding congruent parts. And now we want to write a congruency statement. A congruency statement is what's written up here. It identifies your two polygons or two triangles as being congruent. Now the key to the congruency statement is that order matters. So the first thing we have to do is we just have to name the first triangle. So we do that by drawing a triangle symbol. And then we name this triangle in whichever order we want to. So let's say we name this triangle as JP JPL. Just make sure we work our way around the outside. So triangle JPL would have to be congruent to triangle, and then we have to look at angle J. Well, what angle corresponds with angle J? It's angle T. So we need to start with angle T. P is our next letter. So here angle P corresponds with V. So V comes next. And S will be our last because S and L correspond. So our congruency statement would be triangle JPL is congruent to triangle TVS. Okay, so once again, notice that angle J and angle T, those two are congruent to each other. Angle P and angle V, those two are congruent. And angle L and angle S, those two are congruent. This also works for sides. Side JP and side TV, those two are congruent. If we look at our last two letters, PL and VS, those two are congruent. And then if we look at a combination of our first letter and our last letter, so JL and ST, those two are congruent. So that's our congruency statement. We're going to use this information now to do some solving. So here we want to find x and y if triangle ABC is congruent to triangle FDE. Well, if they're congruent, that means that their corresponding parts have to be. So that means A has to be congruent to F. So those two angles must be equal. Notice that we already have some other equal marks on here. Well, right here we have angle D and angle B marked as congruent. Angle B is 48 and angle D is Y, so we know Y is 48 degrees. Now we want to figure out what angle X is. Angle X is right here. X minus 2Y is at angle F. And up here that should equal our angle A. Well, we don't know angle A, but we do know two of the angles. So we can do 108 and we can add 48 onto that. And figure out that those two angles added up together is 156. That means our third angle of the triangle has to be 180 minus 156, which means our third angle here has to be 24 degrees. So angle A is 24 degrees. It is congruent to angle F, so that's equal to x minus 2y. Well, we just figured out that y was 48, so we can plug our 48 in for our x. So x minus 2 times 48. And now we just have a simple equation to solve. 2 times 48 is 96. So 24 is equal to x minus 96. To get the x alone, we have to add the 96 onto both sides, which means 120 is equal to our x. So our y is 48 and our x is 120. We're also going to be starting to do some proofs. Proofs mean that we have to justify each step along the way. So there are three types of proofs we can do. We can do two-column proofs, we can do flow proofs, and we can do paragraph proofs. So I'm going to show you this proof done in all three ways. The first way is we're going to do a two-column proof. Two-column proofs means that we have two columns. We have two columns. We have a statement column, and then we have a reason column. So what we're going to do whenever we do a proof, the first thing that we always want to state is our given information. So here's our given information. We just recopy that down. So EF is congruent to FG. EH is congruent to GH. Angle EFH is congruent to angle GFH. And angle EHF is congruent to angle GHF. And our reason why is always given. That's the first step all the time, no matter what. Okay? So now what we're going to do with that given information is we're going to go over to our diagram and label it. So EF and FG are congruent, so we're going to mark EF and FG as being congruent. Then we're going to mark EH and GH as being congruent. And then EFH angle EFH is congruent to angle GFH. So those two angles are congruent. And then angle EHF is congruent to angle GHF. Okay. Now, in order to say that these two triangles are congruent, which is what we are trying to prove, we need to show that the third side is congruent. So we need to show that FH is congruent to FH. And we also need to show that the two angles are congruent. So we need to show angle E is congruent to angle G. We need to show these two things in order for us to say that the two triangles are congruent. So let's start with FH is congruent to FH. That one seems pretty straightforward. We're going to write down FH is congruent to FH. Why? That's called reflexive. Reflexive happens when anything is congruent to itself. Reflexive means anything is congruent or equal to itself. So like A equals A would be reflexive. So side FH is congruent to side FH indicates reflexive. Now we need to show that the angle E and angle G are congruent. So to do that, notice here we have two angles that are congruent to each other, two angles that are congruent to each other in the second triangle. It makes sense that our remaining angles should be congruent. And it makes sense because we know the three angles add to be 180 in a triangle. So that's what we're going to show. So we're going to say angle EFH plus angle EHF plus angle E equals 180. And we'll say the same thing for our other triangle. Angle GFH plus angle GHF plus angle G is equal to 180. And that's because of our triangle sum theorem, which we talked about in the last section. And now it makes sense that because EFH and GFH, these two are congruent to each other. EHF and GHF, these two are congruent to each other. That was in our given. It would make sense that our remaining angles should have to be equal to each other. So that'll be our step 4. Angle E should be congruent to angle G. And the reason why is we can call this substitution, because we were substituting this information in, that EFH and GFH are congruent, EHF and GHF are congruent, so then E and G would have to be. And so now we've written down the two things that we needed to write down in order to prove the two triangles congruent at step 2 and step 4. So now we can say that they are. So step 5 would say triangle EFH is congruent to triangle GFH. And the reason why, all corresponding parts are congruent. So there's our end of our proof, and this is, like I said, the 2-column proof. And so you need to be able to write down a statement and then say the reason why you're writing it down. So there are 2 more methods to writing proofs, both the flow proof and the paragraph proof. And the next 2 slides will show you those 2 methods. And you can always choose whichever method you understand the best, regardless of what the book directions say. So for example, if the book says write a 2-column proof, but you really understand a flow proof or a paragraph proof better, then write down a flow proof or a paragraph proof. That's just completely up to you. All right, so now we're going to do the same thing, but we're going to write a flow proof. Okay? A flow proof is a little bit different, and what we do for a flow proof here is we start off by doing the given, okay, and we write all this given information out. That's going to be consistent no matter which type of proof you're doing. You're always going to write out all the given information. But notice we don't have columns here or anything like that. We're just simply writing it all down together. And then what we do is we put a box around it, and right underneath it, rewrite down given. Okay, so that's how we're going to start the full proof. So then from here, we would do the same thing we did in the previous step, as we would look at the given and we would mark our congruent sides and mark our congruent angles, and we would take a look at where we're going, and we would need to say, okay, in order to prove that these two triangles are congruent, we need to show that the remaining two sides are, so we need to show FH is congruent to FH. And then we also need to show that angle E is congruent to angle G. So that's where we are going. Once when we show those two things, we can say that the two triangles are congruent. So then we start working on that. So from the given, we can go, okay, well, from this given, we can also say that FH is congruent to FH. We'll put a box around that, and right below that box, we are going to write down that that is reflexive. Okay. Now here's a whole nother thought to get the two angles equal. So to show that the two angles are equal, we're going to start a whole new column over here of information. And we will say that angle EFH plus angle EHF plus angle E is equal to 180 degrees. Angle GFH plus angle GHF plus angle G is equal to 180 degrees. We'll box it down, and underneath it we are going to write the triangle sum theorem, because we know that because of the triangle sum theorem, the three angles must add to be 180. Okay? And then from here, we can do the same logic we did in the previous step. We know that EFH and GFH, we know that these two are congruent because it was given to us. We knew EHF and GFH, those two are congruent because it was given to us. The 180s here also line up, so the only thing left is to say that angle E is congruent to angle G, and that is by substitution. Okay, so there we got our second piece of the puzzle written down. And now we want to take both of these lines and combine them together, because we are using all of that information together to show that triangle EFH is congruent to triangle GFH. And we will box that in, and the reason why is we have all corresponding parts are congruent. So that has all the same information as a two-column proof on it. It just has it organized in a different way. Okay, and then the third and final way you can do a proof is called a paragraph proof. Paragraph proof, once again, it's essentially the same thing, but we are going to approach this in terms of writing it out. So we still start with the given. So we're going to say given that EF is congruent to FG, EH is congruent to GH, angle EFH is congruent to angle GFH, and angle EHF is congruent to angle GHF. So given that, then we're going to state all of the given information. From there, once again, you would go to your diagram and you'd mark all of the given information. Okay, and we would look at the diagram, we'd look to where we want to go, and we would identify what else we need to show. So in order to show those two triangles are congruent, we need to show that FH is congruent to FH, and that angle E is congruent to angle G. We need to get this written down at some point in time in order to do so. All right, so given that, we can say then FH has to be congruent to FH by reflexive. we can say by the triangle sum theorem, angle EFH plus angle EHF plus angle E should equal 180 degrees, and angle GFH plus angle GHF plus angle G should equal 180 degrees. So by the triangle sum theorem, we know that those sets of angles both have to equal 180. Therefore, angle E should be congruent to angle G through substitution. So then, triangle EFH should be congruent to triangle GFH, since all corresponding parts of the triangles are congruent. So notice here for the paragraph proof, once again, it has all of the same information that our previous two proofs had. This just has it written out in sentences. And of course, this way works well for those of you who really do well when it comes to writing out your thoughts and things like that. This would be an excellent proof for you to use. So once again, whenever you see a proof, you can choose one of those three methods.